Okay, valid. All right, guys. 4.1. We're going to talk about rational functions. Anybody know what a rational function is? No. It's rational. It's not irrational. Do you know what a rational number is?
Yes, I do.
What is it? No. Oh my goodness. That's very true. Okay. Right. Any number that you could put into a fraction is a rational number. What you're saying about decimals that never end and never repeat cannot be made into fractions. But if it's an ending decimal, if it's a terminating decimal, I can make it into a fraction. If it's a repeating decimal, like 0.66666, right, I can make it into a fraction. Okay? So it's any number you can make a fraction. So rational numbers would be like, I don't know, like 2/5 or 1/3 or the number 7 because I can put it over 1, right? These are all rational numbers. So what's a rational function? Just replace that with function. So it's any function that is a fraction, basically. That can be made into a fraction. I don't know, however you want to say it. Basically, rational functions, you guys, is going to be something with a polynomial divided by a polynomial. Right? Those are rational functions. Rational functions are pretty interesting with the graphs that they make. They've got vertical and horizontal tangents. There's all sorts of cool stuff that we're going to talk about. Okay? But yeah, they're just polynomials. Now, the first thing that we're going to do is we're going to simplify these. Okay? So see how this is like a polynomial over a polynomial, right? It's an equation on top, equation on the bottom. We're going to simplify them. But in order to simplify, this is super important. You need to have factors in order to cancel. Okay? You got to have factors in order to cancel, which is why we did factoring on the warm-up. If you're good at factoring, you'll be really good at this. If you suck at factoring, guess what? You're going to suck at this too. No, sir. So it's time to learn how to factor, my friends. And most of you know how to factor.
Did we just review how to factor?
We did. I mean, I would hope so, but I don't know. Okay. Let's remember back in kindergarten when you guys first learned how to simplify fractions, right? Do you guys remember how to do this? Yeah, you go like, oh, I could divide that by 3. I could divide that by 3, and I get 3/5. Right? What you're really doing, you're not like writing this, but what you're really doing is you're going, like I'll show you on here. 24 is 8 times 3. 40 is 8 times 5. And you're crossing off the 8s. Does that make sense? That's what you're really doing. Right? Or like for this one, I can go, you know how normally we just like cross the 10s off? So I can say, okay, well, this is 10, and then 30 is 5 times 6. This is 10, and 36 is 6 times 6. And then it's like I'm crossing off the 10s. That's what we do when we cross off the zeros. And I'm simplifying the 6s. That's basically what we're doing. So with rational functions, we're going to factor them first. And then we're going to see what cancels out. But it's really important that you factor first, okay? Because you guys will make my head explode if you go through here and you go, oh, look, I could cross off the x squareds. You're not allowed to do that, all right?
What if you just plug it on the calculator stuff?
Nah, it's not going to do it for you. Or you can't come in here and go, oh, look, 7 and 21, I'm going to cross it off. You're not allowed to do anything like that until you factor, okay?
Is that just because it'll mess up our ability to factor?
Well, not only that, but it's just not a true statement. Like 2 plus 3 over 2 plus 7, that's what, 5/9? If I was to do that, that's 3/7. It's just not the same thing. Does that make sense? But if it was multiplied, it would be. So, yeah, so you're not allowed to just cancel out like parts of terms.
So does that mean you can get rid of one of the x? Because x squared is technically just x times x on both of them. So you could...
Right, but no, because it's like it's next to a plus or a minus. So if it was x squared outside of something, then you could. But not if it's like x squared or x plus something. Okay? So we start by factoring. I mean, it's not lame, it's math, but whatever. You're lame. Okay, we go, like for this one, I'm going to go, okay, this is big X factoring, right? As you guys get better at this, you're maybe not going to have to draw your X's all the time, right? You able to do some of these in your head? Maybe? So like this one is X plus 3, X minus 2. Well, I know you can do them in your head because you guys are doing them in your head when you do the warm-ups, basically, aren't you? You're hardly ever writing them down. For this one, what multiplies to make 15? Adds to make negative 2. Okay, positive. No, negative 5, positive 3, because the 2 is negative, right?
Wait. So then now can we just cancel out the common ones like
yes.
X plus 3, get rid of those, then we have X plus 2 over...
That's exactly right.
X minus 2 over X minus 5.
Why am I messing this up so much? Yeah, you're exactly right. So guys, once you factor, just like with the fractions up here, once I factored, I was just using numbers, but anything that was the same I could cross out. Once you factor, anything that's the same, you can cross out. Boom, boom. Okay? So this actually simplifies to X minus 2 over X minus 5.
Is that our final answer?
Yeah. Okay? So all these problems are factor, cross out, factor, cross out. That's all you're doing. Okay?
Can we also technically...
No. Because, yeah, again, it's next to a minus, so you're not allowed to, like, do that. All right? Why can't what? Like the whole thing be negative? Yeah, so here's why you're not allowed to take out the x's. Because, like, so, okay, so let's say I have, let me think of a number. 7 minus 2 over 7 minus 5, right? What does that equal? Okay, if I took out the 7s, because I crossed them off, is that equivalent? No, it's not the same thing. So you're not allowed to cross things off unless it's its own separate term, like x plus 3, x plus 3, okay? You're not allowed to cross things off unless they're multiplied. So like on here, if it was added, I can't, but if these are all multiplied, that's when you're allowed to cross things off, all right? You can have different types of factoring, like number 2 on the top. What kind of factoring is that?
Squared.
GCF. We can call it normal, but GCF, right? Every time you look, you think, can I take something out? What can you take out of 7x minus 49? 7, right.
Is the answer 7 over x plus 3?
Yeah. And then we take this and we go, okay, that's my x problem. Negative 21, negative 4. What makes it? We are going to do minus 7 plus 3. And then the minus 7s cross out. All right. I mean, it's possible to have a problem where nothing crosses out, but I'm trying not to give you any of those. So if you do it and nothing crosses out, just check your factoring and make sure that, like, you did it correctly, you know?
Trying not to. Does that mean if we run into one, like only one in the homework, it might be...
No, I checked the homework. They all
So
factored.
there won't be any.
No. There's an option where I can say include problems that cannot factor, but I didn't do that. You know? So everything I'm giving you, they'll factor. Okay? This is both big X's, right? So you guys, what multiplies to make positive 70 adds to make negative 17? Yeah. And if you can do this without making the X, great. It goes that much faster, you know? And what multiplies to make 90 and subtracts to make 1? 90 and 1. If it subtracts to make 1, it's going to be two numbers right next to each other. 9 and 10. Holy crap. Christmas really did a number on your guys' brains. Woo! Okay. And to get -1 minus plus. I just forgot how to multiply numbers. Boom, boom.
That was the greatest question I have heard in years, man.
You got it? You good? What happened to what? What? Are we good? Okay. Raina, pay attention. Now we get a little bit tricky here. You guys ready? It's tricky. All right. Look at the top. What kind of factoring is this? Yeah. Take out the 4 and you can take out x. Yeah. So that's called GCF. When you can take something out, you always want to try to take something out first. When I take out a 4 and an x, I'm left with x minus 3. Okay? That's nice. Now, this, I want to see if I can take a number out because that would be really helpful, but I can't because 3, 16, and 21, I can't take anything out, right?
Aren't you supposed to like take a 3 and a 21?
Yes, so this is one of these problems. But it's not too bad. What's 3 times 21?
Don't worry, I can do that.
Okay, and what multiplies to make 63 and adds to make 16?
Yeah, -9, -7.
9, 7. 8, 8 would be if it was 64. So close. Yeah, 9, 7. Both minus. Now, you guys, this is one of these crappy problems with, we call this a leading coefficient with a number in front. So you got to do this thing. Okay? You remember, right?
I don't remember anything.
We literally did this last semester so much.
Did we?
Yeah. So look, yeah, no kidding. 9 over 3 is 3. That divides evenly. Now, 7 over 3 does not divide evenly. So what do I write? -7, put the 3 up.
Oh, we're so smart.
Guys got it? I mean,
You can tell because we're so good
okay.
Especially you.
My friends. All right. X minus, whoa.
Also know that 9 and 10
You know, it took you a bit of time on that, though. X minus 3 crosses off, and I've got 4x over 3x minus 7.
There's really no way to factor it anymore, make it look better.
Nope. That's as good as it gets, man.
What if we is there no way to put the 7 on top and then take 4x and put it on the bottom?
No. That's it, man. That's all you can do. I know. Now, do you guys remember how to multiply fractions? Yeah, I can multiply the top, I can multiply the bottom, and then I can reduce it, right? Yeah, so like 10 over 18 would go to 5 over 9. Is there a faster way to do that? Do you guys remember how to do that with fractions, a faster way? What'd you call it? The butterfly. I love that. Aww. The butterfly. Okay. Yeah, that's right. You can cross cancel, I guess. Also known as the butterfly, right? You guys, so like I look here, can you cross off 2 and 6? 1, 3. Can you cross off 5 and 3? No. So then it's just 5 times 1 and 3 times 3. And you can go directly there and just skip that middle step. Okay? So that's called cross-canceling. That's called cross-canceling.
Does that really save that much time?
Yes, on something like, not on that problem, but on this one. Because can you do 12 times 49?
Because then you can just put that as 1 and stuff.
Exactly. So yeah, it'll save you time here where you go like 1, 7, 4, 5. Yeah, so it's a lot faster if you can cancel out first, because I'm not going to be able to do 12 times 49 in my head.
948. Wait, you can't do that?
What?
You can't do 12 times 49.
Can you? I actually can. Ready? On your mark, get set, go.
Wait, what? No, I'm not.
588. Check me if I'm right. 588.
I'll do it now.
588.
588. Yeah.
Let's go. All right.
No, you just do 12 times 49.
But he's impressed with me. Okay, you guys, you can cross cancel, right? You can also cancel anything like that. Anything on the top, anything on the bottom. It doesn't even have to be cross. You know what I'm saying? But it can be. You'll get the same thing either way. So like here, 30 and 50, I can do like 3 and 5. You know? So you don't have to go across. You can go straight up and down.
It's not really a cross because really when you're multiplying it, you're just extending the line between them and then all four.
Exactly. Everything on top, everything on bottom.
If you just rearrange them, it would be just on top.
Exactly. 5 goes into 45 9 times. 3 goes into 120 40 times. 9 over 40. 9 over 40? Oh, yeah. Okay. Guys, that is the same thing that we're going to do here. There's just a crap ton of more, like, factoring to do. No big deal.
Oh, what the heck is number 7?
Oh, it's not even that bad.
Disgusting.
Don't cry.
I'm crying. I'm bawling.
Guys, what kind of factoring is x squared minus 64?
Gross. That's the perfect square thing, right?
The perfect square thing.
You can do for that. Oh,
Right? Okay, so don't forget perfect squares. We reviewed that. Perfect squares, x plus 8, x minus 8. Yeah? Okay. What kind of factoring is 3x plus 24?
You can just take it out. That's the
Take out, yep. That's a GCF. Boom.
Oh, so now you can get rid of one of those.
Yeah, for sure. X minus 6 doesn't do anything. What about 10x minus 60? Take out the 10.
Oh, wait, and then you can get rid of those. And you just have times 10.
Yeah, now it's the fun part. I feel like it's so satisfying. Boom. 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 Zach. Wow.
You're gonna have to get reported on Safe Utah now. You know what? There's always like police cars driving by. They're coming for you.
Safe Utah. Oh my goodness gracious. Okay. So x minus 8 over what's left on the bottom? 3 and 10. Yes. So if you have 2 numbers left, that's what's up, Carol. Good job.
It came from the term that you killed.
So satisfying. You are not wrong.
I thought you were. Yeah, I thought you were writing it.
I know. Nobody likes it when it's not X's, but it's fine. We can handle
It'd
it.
be so cool if it ended with just like 12 or something, like that huge, crazy equation.
And then it just like ends to.
I thought
You right?
I thought you were writing out like the problem with all the crosses.
Okay, I got you. Okay?
Next try to say.
I mean. Okay, this one, that's the big X. But see, I'm getting good at this, and I think I can do that in my head, right? Can you guys do that in your head? Hey, Miriam, you okay? Go ahead. Okay. So,
Like 3m and negative 3m.
3 and 2. Right? Do you guys not see how I got that?
Yeah, I do.
Because I'm doing an X with this. -6, +1. But as you get better at this, you can go a little quicker, right? Okay, there's an M plus 3.
You couldn't tell where the number 10 came from.
Bro. Between the two of you, I swear, I don't know who's going to annoy me more.
Oh, I trust me. You know who's going to annoy you more.
Actually, I do know who's going to annoy me more.
I
Okay.
graduated from B3. I know degree in annoyance.
Yes, you do. If I take out a 4, M plus 6, right?
Sure.
My Apple Pencil's running out of ink. Okay. And then this, what multiplies to make negative 12 and adds to make 4? Okay, plus 6. Oh, frick. Plus 6 minus 2. Dallin, you ready for this?
You don't even have to really think about it.
You ready for this?
You can write it so that they cancel. So if you see
I'm probably going to. I might not.
You just said that all the ones on the
Yeah,
top
you're
are
right.
So all we have to
You're
do
right.
is look at the top one, then we already know what are the factors.
You're right.
So then we just have to find the other one by multiplying. Which
Hey,
makes it way easier.
check it out. M plus 3, M plus 3, M plus 6, M plus 6, M minus 2, M minus 2.
Hey, Zach, do you know where the 4 came from? Yeah, I do. Okay,
So satisfying. Hey, let me ask you guys a question. Isn't that so satisfying?
We don't even have to know what N is.
No, exactly. It doesn't matter. So that's 4. No matter what, it's going to be 4. Now, you guys, if the 4 canceled out 2 and there was nothing left, what would your answer be? 1, not 0, right? If everything cancels out and there's nothing left, your answer would be 1.
Is there a way to solve
Okay.
for M? No.
Well, technically what this is, like, if I were to take this is a really good question. See, I'm so excited. I want to teach you, like, more stuff and fill your brains with cool stuff. But I'll teach you in a minute. Yes. If I were to graph this, that whole thing, I would type it all in with X's or whatever. Do you know what it would look like if I were to graph that?
Would it look like a straight line like this?
It would look like a straight line at 4.
Oh, yeah.
With a couple of holes in it. But I'll tell you about that next week.
Wait, what? No, you can't.
I can't do that?
No.
All right.
You can't grant us this knowledge without the full knowledge.
Every time you cancel something out, like M plus 6, M plus 6, there's a hole at negative 6 because you're doing 0 over 0. It's really cool. That's actually calculus stuff, but I'm going to teach you guys that. So there'd be a hole at positive 2 and a hole at negative 3. So if I were to graph that, it would be like a straight line because 0 over 0 is indeterminate. And with calculus, we can do limits. It's really cool, actually. Yeah, it's really cool.
So will we learn more about that next year?
Heck yeah! I'm going to teach you a little bit about it next week, but yes, you will. This is actually the first lesson in calculus is all about limits, and it's like this type of stuff. It's pretty interesting. Okay. Anyways, yeah, we can just put that over 1, right? Yeah, these are all x things, and they're pretty straightforward. X plus 5, x plus 10. That one is, oh crap, n. Well, whatever. Do we care? I guess. I don't know. N plus 5, n plus 10. 11 and 28 is 7 and 4. 4, 7. Now, look at this one on the bottom. Can you take out a number?
Yes.
Thank goodness. Because, well, otherwise I'd have to do 3 times 60 and that blows. But I can take out a 3 from each of those and do n squared plus 9n plus 20, which is way easier to factor, right?
But just to prove the concept, you should test it out by just doing.
Ugh, why would I want to? Actually, to be honest with you, it doesn't work. If there's a GCF, bottoms up doesn't work. It eliminates the number that you should have factored out in the beginning. It just does. I'll show you. Yeah. So it's, wait, what multiplies to make 20 and adds to make 9? Okay, so 4 and 5. So n plus 4, n plus 5. But don't forget that there's a 3 in the front because I took that out. Okay? You guys see where the 3 came from?
Oh, and N plus 5.
Yeah.
N plus 5 also.
And then we go cross, 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 cross.
But then that's still kind of gross.
I mean, it's not great, but it's okay.
Do you want us to multiply those together?
No.
Okay.
So at the end, you don't ever have to multiply them back out again.
Compared to the beginning, though, it is a lot better because the beginning was disgusting.
Exactly. Exactly. It's like that. So what is this? So if I were to graph this and this, it would be the exact same graph. The only difference would be there's a bunch of holes in it. Yeah, there's just like little holes in it and stuff. But it's the same thing. It's pretty cool, actually. Okay, nice. Let's do this last one really quickly. Yo. No. No. This one would have holes in it, and if I graphed this one, it wouldn't show the holes. It like fills in the holes because we canceled them out. Yeah.
Everything to the left of it and to the right to an
Right. And then it just goes like that. That's what a limit is. That's what calculus is. Okay? I want to teach you calculus now, but we got to learn all this stuff first. Oh, it's cool. You don't worry about that. Okay. 5x minus 3. I can't do anything with that. Okay. Oh, sad days. I've got to do this bottoms up thing, right? It's okay. It's all right. Okay. 15 negative 8 minus 5 minus 3. Bottoms up. Okay, cool. So then I'm going to get minus 1. You didn't follow that? All right. Courage, you good?
Can we just cancel it out now? Because it looks so
I mean, you can. It's begging to be crossed out. Okay, so guys, look, watch. Now, you see the difference between, okay, factoring this one that starts with a 3 and factoring this one that starts with a 3.
Well, because not all the numbers are divisible by 3.
Exactly. This one I could take out a 3 and make it really easy factoring. That I can't take out a 3, so I got to do the bottoms up thing, right?
24, which I'm guessing is like 72.
Yeah, good guess. All right. So if I can't take out a 3, I got to do this bottoms up mess, right?
Oh, but 72 is a gross. Oh, no. 72 is 80 or
72 and 1 is easy peasy. What do we got?
8 and 9.
8 and 9.
I can't think that far.
Well,
Plus 9.
You have to have
Now, remember what do we got to do next?
Well, you have to divide by 3, so you'll have 3. But then for the other one, you'll have to have 3x.
Yeah. So, guys, yeah, this last step, if this divides 9 and 3, beautiful, it's x plus 3. If it doesn't divide, we got to bring the number on the bottom up. So I have to write 3x minus 8.
Why does that work?
Oh, just wait. Now, boom, 15 and 40, what do they divide by? 5, and you get 3 and 8, so 5. 3x minus 8. Oh, here we go, right? Cross, 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 cross.
My paper's so messy, you don't even know what to cross.
Well, write neater.
Well,
Now, what do I have on the bottom? I have a 5 and an x minus 1. Guys, you never have to multiply it back out. Just leave it like that.
hey, wouldn't that be cleaner though if you had 5? It would literally just be
5x minus 5?
One to be smaller because you got rid of the parentheses.
You could do that if you want.
So why don't we?
Because typically when you're moving on to the next step, you want it factored out. So for example, this is what we're going to learn next week. The next step is now graph that equation. Now the reason I want this factored out is because I can tell that it has a vertical asymptote at x equals 1. So like if it's factored out, you can do these things faster.
So it just gives you a little more information.
Exactly. It makes it a little quicker, yeah. Okay. Friends, do you remember how to divide fractions? Dividing fractions? Common denominator is adding and subtracting, which we're going to do next time. Dividing is multiplying by the reciprocal, right? Or, as some teachers like to teach it, keep, change, flip, right? But keep, change, flip is weird. So, okay. So guys, look, remember, you change that, you flip that, right? And then you do the same thing we were already doing. Make sense? Keep, change, flip. Yeah. So like this one, keep, change, flip. I can go 5 and 15, that's 1 and 3. 12 and 32, 4 goes into that, right? 3 and 8. So I get 9 over 8. Right?
Oh, I should be doing this. Oops.
Yeah, yes, sure should, kid. 3 over 5. 40 over 27. Ooh, so easy. 5 goes into 40 8 times. 3 goes into 27 9 times. 8 over 9. Sorry. Guys, it's fractions! All right.
It's not Monday.
I am sorry.
Because if it was Monday, my paper would be shredded already.
I'm just going with but so these would cross out, right? What
Yeah.
about these?
Yes, those can cross out, but you have to do something special. If I'll show you in a minute, but yes, they can, but there's a little trick. Okay. Guys, did we get all our fractions? Are we good? Check it out. All right. So I keep the first part the same. I flip the second part. Now, guys, what I do is I flip and I factor in the same step because it's less writing. Am I going to confuse you guys if I do that? Okay. So I'm going to factor that, but I'm going to put it on the top.
Oh, no, that's not bad.
Is that cool?
You have an arrow there. Yeah, makes it pretty clear.
Yeah. Okay. So I don't want to confuse you, but I'm going to flip it and factor it at the same time. That's a GCF problem. Okay, guys? I could take out a 5x. Yep. And then it's 9 minus x. And then I'm going to put that on the bottom. Yes. Now, I got to show you guys something real quick, okay? You can see you cross off the 5x's, that's fine. I'm going to show you a trick about something real fast. If I have x plus 5 and 5 plus x, can you cross those out?
Yes.
Yeah, those are literally the same thing, right? Because it's plus. Boom, boom.
But not
Right?
subtract.
Right, with subtract it's a little weird. If I have x minus 7 and 7 minus x, are those the same thing?
No.
Almost, but no. What's the
Negative
difference?
7 plus x if you want.
Right, and you can factor out a negative.
Yeah.
Okay, so guys, if it's flipped around like this, here's the trick. Cross it out, but put a negative 1. Okay?
Replace it
Replace with a negative 1, or just put a negative somewhere in your problem.
on which
Yeah, doesn't matter.
Just
You can go like the
somewhere.
top, the bottom, the beginning, it doesn't matter.
So negative 7.
Yeah.
You put it by your name.
You just put a negative somewhere. Yeah, so because like if you think about it, if I had like 4 minus 7, that's negative 3. 7 minus 4 is positive 3. It's always going to be just negative 1, you know?
Yeah.
So yeah, if it's plus, it doesn't matter if it's flipped around. If it's minus, you just go like this. So I go like this, 5x, 5x. I go cancel, cancel, and I just put a negative like somewhere. Like I said, you can put it in the front with the 7 or whatever.
So for plus, you can cancel.
Just
Minus,
normal.
It's negative 1.
That's right.
Multiply, you can cancel.
Yeah. Divide would be like different. It would be a reciprocal type thing, but yeah, it would be different. Yeah, it's just negative 7. Woo. So if I graphed, guys, so if I graphed this, you know what it would be? A line at negative 7 with a bunch of holes in it.
Well, it depends on what you mean by that, because like there really wouldn't be a way to tell unless you did
Actually, no, I actually do want to show you guys this.
see it on any graph.
You kind of can. I'm going to show you guys this just because I think it's like so freaking interesting, okay?
Just decimals.
I can't help myself. Yeah.
Oh, does it put like a white dot? That's
7 over, kind of. I'll show you how you have to see it. Over x minus 9. We did divided by it, right? And then it's 5x over 45x minus 5x squared. Did I type it right? Why isn't it doing it? There we go. Okay, you guys, you see I told you, if I were to do this, because I got -7, it graphs a line at -7. You guys see that?
So we are technically solving.
Now, where is there going to be a hole? What did we cross out?
9, wait, so.
X minus 9, right? Okay, at 5x. Okay, check it out. You guys, this is cool, but you gotta watch. Look. It is cool. Zag, not apparently. It just is. Wait, hold on. Oh, wait, hold on. It's really difficult. You gotta have steady fingers. No, you guys see it?
If you click your right, oh, you don't have the right arrow.
Boom. Oh, gosh, damn it. Anyways, you guys see the little point right there?
No, I don't see it. I don't think it's there.
I got it. My hand is like shaking. There's a hole right there because we crossed off x minus 9. So there's a hole because technically that's not defined over here. Okay. No, you have to actually like put your finger.
The hole, no matter how much you zoom, it's always going to be just as small. Because the more you zoom, the smaller numbers you're putting up, but those will still be just as
Okay, right. And so what we use is something in calculus called a limit to get infinitely close to that. Right? So I can tell where the hole is going to be by using like calculus and stuff. But anyway, there you go.
So cool.
Anyways, so these will always come out to whatever equals to. That's what it's going to graph, but with some extra holes in it. Okay? It's really cool. All right, let's finish these up real quick. Okay, that's GCF. I could take out a 2 and get 2n minus 3. That's GCF. I could take out a 2 and get n minus 3, right? Flip it. Now, I'm going to put that one on the bottom, okay? I can take out from here a 6n squared, actually. 6n squared. So what's going to be left if I take out a 6n squared?
You're looking at
Yeah, because remember, I'm flipping it. I drew an arrow for you and everything.
Then you'll have -3 on that side.
2n minus 3. Now, I said don't let me confuse you when I do this. Now I'm going to take the part on the bottom and put it on the top.
And so you just have to.
Little X Games action. 2 times 3, negative, negative.
Yeah, that's 6 to the left. Oh, no, but it definitely works.
Yeah, because your signs would be off. Okay, we ready for the crossing off part? So then I go, boom, 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 boom. Hey.
I don't feel like. No, wait, no.
Cool, right?
Scribble, scribble, scribble.
Scribble, 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 scribble. Die, 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 die.
Do you have like a quick talk or something there?
He's like super violent.
Well, that's the problem. You're having fun murdering 4 numbers.
So guys,
Turn back here like a red head, just like jabbing.
are we feeling slightly better about factoring after all this? Like, have we done enough? Please don't tell me you still can't factor. Carolyn, what multiplies to make 21 and subtracts to make 4? 21, 4. Oh, you're not Carolyn. Carol. Abby. What? Sorry, Abby. What multiplies to make 21 and subtracts to make 4? I lost my mind over spring break.
Spring break?
Yes, I lost my mind over spring break.
Spring break. Well, clearly you
Right?
lost it.
No, I don't think you know. Okay, look. This one. What do you do, Abby? I'm sorry I called you the wrong name. Oh, I called you Carolyn's over there, but you both like in the back. That's where it comes from. Okay. Whatever. Then I flip this, so that goes up, and it's 8. And then I flip that, and what multiplies to make 35 and adds to make 12?
Well, I want to bet that there's a -5 in there.
What multiplies to make 35? And adds to make 12?
-7, -5, -7.
Let's go. Yeah, you're right. Boom. Whoa. I actually erased it. Boom, 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 boom. Boom, boom. 2.
Oh, it's just 2. Let's go.
Let's go. Am I right?
So now we know it'll just be a line at 2 with a whole bunch of them.
That's right. Exactly. Isn't it fascinating? Guys, I know. Same thing here. I just have to put a 1 underneath. Okay, check it out.
Yeah.
That regular x, okay? Oh, I'll show you. -5 plus 1, right?
Yeah.
Now, you guys, this. What can you do with 4x squared minus 100? You could take out a 4.
They're kind of gross, but you get x squared minus 25.
Good, good. Okay. This I'm flipping, right? And now this I have to do ugly factoring. We're going to call this ugly factoring from now on.
Where you just take out
-2, -7.
Plus 2 minus 7.
enough room on my paper for this.
Divide by 2.
Is that 1x?
Well, eventually I want you to do it in your head.
Plus 1.
The whole thing. Oh yeah.
That's right, Ethan. Yes. Now,
Zach, if I hear kill, like come out of your mouth.
kill, 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 die, die, die.
That is a great solution.
Yo, guys, hang on. Maddie has something to say. Because right now, we only have that to cross out. What can you do? Yeah, you guys, what is this right here? X squared minus 25?
It's a perfect
Perfect square. We could go again. We can keep factoring that bad boy,
And
right?
it's notably the perfect. It's just squared x minus 5.
Yeah, well, it's 1 plus 1 minus, remember?
Yeah.
So that could keep factoring and give me an x plus 5 and an x minus 5, and then I could cross off more things.
Because now the bottom is significantly more disgusting than the top, which is the 1.
Yeah, that's all right, though. It'd be better than if I had x minus 5s on there.
Because then you have like the shortest thing possible on top, and then like everything else on bottom.
Beautiful, am I right?
Sure. Is there technically one
Not as beautiful as me. No. No. Why does it bother you so much? It's all right.
Actually, it does look pretty good.
It's pretty nice.
It's really simple.
It's really nice. Yeah.
Now we go through the whole.
Yeah.
Whoa!
You guys do the homework. All right, so you guys have homework. Look for simplify, multiply, divide. You guys got this, all right?
Hey, Zach.